Get you chuck your pens down and just watch, and then I'll leave it up and you can copy it in your own time if you would like it. So composite functions, this word gives it away. Composite, composed of. This means we have functions that are composed of, they're made up of other functions. So here I've got the function notation. We've got f of x, some function with regards to x. We've got g of x, another function with regards to x. Here it says find f of 0. That means you take the number 0 and you put it into f of x everywhere there's an x. So we're going to take the number 0 and put it there. We would have 2 times 0 is 0. So f of 0 would equal 1. Alright, that was function notation. We did that in 3b. What we're doing in composite functions, so maybe I'll write that out. We put 0 where the x is. That's going to be the function when we have 0 where the x is, and that means 2 times 0, which is 0 plus 1. The answer is 1. Okay. What we're doing in function notation is it says find f of g of x. It means find the function that occurs when you take the whole thing of g of x and plug it into f of x. It's like f of x is going to gobble up g of x, it's going to eat it. All right, so we're taking that whole function and we're putting it in here everywhere there's an x. It's going to be 2 times, and then you can see we've got 2 times x. We're putting g of x there. We're going to have 2 times 3x take x squared. All right, we've put the whole g of x function right there, and then there's this plus 1 hanging out the side. Okay, it's gobbled it up. And then we'll probably need to simplify them a little bit. So we can expand this. We're going to have 2 times 3x will be 6x, and 2 times minus x squared will be minus 2x squared, plus 1 hanging outside there. All right, so if we have f of g of x, then we're putting g of x function into f of x. What about if we have g of f of x? This time we can see g of x is gobbling up f of x, isn't it? G of x is the big one, and we're going to put f of x into g of x. All right? Why? Because it's the one on the inside. All right? So we're going to put f of x everywhere there's an x. We're going to put it there, and we're going to put it over here. So this is quite a long one. If we have g of f of x, we're going to have 3 times, what is f of x? 2x plus 1. And then we have take away, and then we're going to plug it in again here. 2x plus 1 squared. Okay, so that's the skill we're learning today, is the substitution. That's the important part. Taking this function and plugging it in there. What I'm going to do next with this one is expand and collect like terms. Now these are algebraic skills that are sort of assumed knowledge, but I understand some of us, we're still developing it. So I'm going to perform the algebraic skills that show you how to expand it and collect it. So firstly, if we look at this one, we're going to distribute that 3 amongst both of them. So I might rub this one out, and I'm just going to work downwards, I think, and I'll do that one up there. So if we distribute the 3, we're going to have 6x plus 3. 3 times 2x, 3 times 1. We have take away, and I'm going to leave that negative out the bracket because when we expand this, that negative needs to distribute to every term. So I'm going to leave it out the front. And then here we have a perfect square. 2x plus 1 squared. What does that mean? It means 2x plus 1 times by 2x plus 1. That's what it means. So you could do a FOIL there if you feel comfortable doing FOIL. What we should be looking at using is the perfect square rule. A plus b squared is a squared plus 2ab plus b squared. Okay, so perfect square expansion, if we have an expression like this is what it expands to. Here we have 2x plus 1 in brackets squared. So we can see this corresponds with A, this corresponds with B. All right, and so then we just follow the formula. We're going to have 2x in brackets squared, A squared, plus 2, always the number 2, multiplied by the A value. What is A? A is 2x, multiplied by the B value, which is 1, and then plus the B value squared. That's what that expands to. You can use FOIL, you can check it, but we've got A squared plus 2ab plus b squared. Okay, and then what this is going to become, here we have 2x squared, all right, 2x squared is, the square needs to apply to the 2 and the x. So it becomes 4x squared. All right, so we've got 6x plus 3, take 4x squared. Here, this is 2 times 1, that's 4x, and then we have plus 1. Okay, so that, when you fully expand it, this is what it becomes. This and this are equal, they're just different ways of representing it. We've expanded it. Okay, now what we have to do is that negative needs to distribute here, here, and here. All of those terms are going to become negative because this negative applies to all of them. It's out the front of the bracket. So we have 6x plus 3, take 4x squared, take 4x, take 1. And then we're going to, so now we've fully expanded it, we're ready to collect like terms. So like terms have the same variable, yeah? So 6x and minus 4x, we can collect them together. We've got 6 lots of x, we take away 4 lots of x, we're left with 2 lots of x. They're like terms. We have positive 3 and minus 1, we can collect them. Positive 3 take away 1, that simplifies to 2. Okay, so we collected that, we're just left with minus 4x squared hanging out by itself. So that's quite a complex expansion, right? So this was the expansion, all of that was the expansion. Okay, that's sort of algebraic processes we're developing and learning. Hopefully we've seen a bit before, but the new skill is the composite function, where we take the function and we put it in. What also follows from this is you might have something like g, I'll write it here, g of f of 1. G of f of 1. Just like f of 0 means put the number 0 where the x is, g of f of 1 means put the number 1 into the function g of f of x, right? And so you could put it in here, or you could put it in here. These are the same function. Look, equals, 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 equals. It's the same function, different ways of writing it. If we put the number 1 in, we're going to have 2 plus 2, take 4, 0. Okay, we get 0. F of 1, g of f of 1 equals 0. You can see the same thing up here if we were to evaluate it. All right, so different ways of writing the same thing, this function here. Okay, so there's that. And then the last one was f of x. Okay, f of x. What that means is you take the function f of x and you put it everywhere there is an x inside f of x. So the normal f of x function, right, is 2x plus 1. And so we're going to take the f of x function and we're going to put it where the x is. So it becomes 2x plus 1 plus 1. See? 2 times x, that's where we're performing the substitution for the same function, plus 1. So you will see that one pop up as well. That one can be a bit tricky. So the skill we're focusing on then is that substitution, putting one function into another and simplifying it, seeing what it ends up with. Just a quick word on notation. Me, other maths teachers here, this is the notation we're going to use, f of x. We're going to use the brackets. The text and SACE, like we do that because the SACE board uses that notation. The textbook uses this because the textbook is trying to cater to Western Australia as well, so they have this funny thing, but it means the exact same thing, right? Whichever one's written first is the big one, whichever one's written second is the one that's getting gobbled up. Okay? So I would like us to try this exercise, even if we're not finished with the domain range, let's leave that for now. Let's move on to exercise 3D. Any questions about explanation here?